Hello everyone. In this session, we will talk about properties of integers. Let's talk about closure property. So first, let's look at the addition. So if I take an integers -4 and -6, both -4 and -6 are integers. So if I add them, -4 plus -6, what I get, -4 stays as it is. Two successive signs here, plus and minus, different signs means I will get resultant as -6 here, -4, -6, minus, same signs means addition. So 6 plus 4 is 10, and the answer gets sign of the bigger number. In this case, it is 6 and the sign is minus. So the answer is -10. So if you observe here, -4, -6, -10, all the three numbers are integers. Hence, we can say that in this case, the integers are closed under addition. Let's look at some other integers, -4 and +3. So let's do the addition. -4 plus +3. -4 comes down as it is. To successive signs, plus equal signs means resultant is addition, positive sign. So -4 plus 3. Now here one is negative number, another is positive number, different signs, which means we have to do subtraction. And let me do the subtraction in rough area. 4 minus 3 is equal to 1. So 1 comes as the answer, and the answer gets sign of greater number here, and the greater number is 4. So sign of 4, which is minus, the answer gets minus sign. Now again we can see that we have -4, -3 and -1. All three are integers. So now we can very well say that integers are closed under addition. Let's look at the subtraction now. So let's take the same integers which we took there. So -4 and -6. Now -4, -6, let's do the subtraction. -4 minus -6. -4 stays as it is. Minus, same sign. Same signs means resultant sign is going to be plus 6. One is minus, one is plus, different signs, which means we have to do subtraction. So let's do subtraction in rough area. 6 minus 4 is equal to 2. We get answer as 2, and answer gets sign of the greater number. Greater number here is 6 and the sign is plus, so the answer is plus. So now here we can see that -4, -6 and +2, all three are integers. So in this case, we can again say that integers are closed under subtraction. But let's take another example first. So let's take the same number which we took last time, -4 and +3. Let's subtract them. -4 minus +3. -4 stays as it is. Minus and plus, different signs. So resultant sign is minus. Minus, same signs. So the operation is addition. 4 plus 3 is 7. And we get the sign of greater number, which is 4 in this case, and sign is minus. So answer is -7. Now again we can see clearly that -4 minus +3 and -7, all three are integers. So now we can say that integers are closed under subtraction as well. So I made a chart here. So closure property, we can say that integers are closed under addition and they are also closed under subtraction. Let's now talk about commutative property. The commutative property states that whenever we are doing operation, if we physically interchange the position of the numbers, the result does not change. So that means if I have operation A plus B, I physically interchange the numbers. I move A this side, and in that case, this becomes B plus A. So when I do that, the result should be equal. That is what the commutative property says. We'll again do it for addition and subtraction. Minus 4 and minus 6. Minus 4, minus 6, we are going to do addition. In first, we'll do minus 4 plus minus 6. And then we'll do minus 6 plus minus 4. So we'll interchange the positions. So let's do the first one. In the first one, minus 4 stays as it is. Plus and minus successive signs, different signs always result into negative. So we have minus 4, minus 6. Now, again here, two signs, they are same, minus 4 and minus 6. Same signs, they result into addition. So 6 plus 4 is 10, and 10 gets the sign of greater integer here, which is 6. 6 sign is minus, so answer gets minus. Now let's see here. Minus 6 stays as it is. Plus and minus successive signs result into different, because they are different, they result into minus. Again, we have minus 6, minus 4, two negative numbers, same sign. So they result into addition. 6 plus 4 is 10. 10 gets the sign of higher number, which is 6 here, and the sign is minus 10. So we can see that the result is equal. In both cases, we get minus 10. Let's see if the same happens for another combination of integers. We'll use minus 4 and plus 3. So let's first do minus 4 plus 3, and then we'll do here minus, no, not minus 4, plus 3 plus minus 4. Okay, so let's do this. Minus 4 stays as it is. Plus plus, same sign, results into positive. Minus plus, different signs result into subtraction. So let's do subtraction in a rough area. 4 minus 3 is equal to 1. So that gives me 1 here, and 1 gets sign of the greater number here, which is my 4, and its sign is minus. So minus 1 is the answer. Now in this case, let's do plus 3 remains as it is. Plus and minus both convert into minus. So now plus and minus here, in this plus 3 minus 4, plus minus means it is subtraction. Again, we have to do the subtraction in the rough area in the same. So 4 minus 3, I get 1, and 1 gets sign of the greater number, which is 4 in this case, and sign is minus 1. And now we can see here once again that both the answers are equal. So now we can confidently say that integers are commutative under addition. So let's now see what happens for subtraction. Let's take the same numbers which we took earlier, minus 4, minus 6. First we'll do minus 4 minus 6, and then we'll do minus 6 minus 4. Let's perform it here. It gives us -4 as it is. Minus minus, same signs result always into plus. So -6 plus 4, -4 plus 6, minus plus different signs. So it is a subtraction. Let's do that in the rough area. 6 minus 4 is equal to 2. So I get answer as 2. And answer gets the sign of greater number. In this case, it is 6 and the sign is plus. So my final answer is +2. Here, -6 stays as it is. Minus minus, different signs always result into plus. So it is -6 plus 4. Now this is one number is minus, another number is plus. So which means it is a subtraction. Different signs means subtraction. We have already done that subtraction here. So 6 minus 4 is 2. We'll take the answer 2. The answer gets sign of greater number. In this case, the greater number is 6, which is whose sign is minus. So answer gets minus. Now we can very clearly see that they are not equal. They are, one is +2, another is -2. So they are not equal. The integers are not commutative under subtraction. So we know integers are commutative under addition and integers are not commutative under subtraction. Now let's talk about associative property. Associative property talks about change of order of operation. So to give an example, if I have A plus B plus C, as per BODMAS, what I'm supposed to do is, if I have the same operation, so first we have to do the operation on the left hand side. So in this case, we will do A plus B first. We'll do A plus B first. So we'll put a bracket on A plus B. Now, associative property says that even if you change the order of operation, which means instead of doing A plus B plus first, I do B plus C first. So in this case, I add A plus B, and to the result of A plus B, I add C. But here, what I'm doing is I'm first adding B plus C, and the result of B plus C, I'm going to add into A. And if they are equal, we say that those numbers are associative under addition. So let's again take some numbers. -4, -6, and +3. Okay, so let's first add -4 plus -6 plus +3, and then we'll add -4 plus -6 plus +3, and we will change the order. So in this case, we will add these two numbers first, and in this case, we will add these two numbers first. So we'll change the order. Okay, so solving inside the bracket, we have -4 stays as it is. Plus and minus, different signs always result into minus. So -6 plus +3. -4 -6, same sign, which means it is going to be addition. So 6 plus 4 is 10, and sign of the greater integer, here it is 6 and sign is minus, so we give minus sign to this, plus +3, -10 plus same sign results into positive sign. So +3, minus plus is subtraction. So let's do the subtraction in rough area. So 10 minus 3 is equal to 7. So answer is 7, and it gets sign of greater integer. So it is 10 here, and 10 sign is minus. So we give -7. Now we will do the same thing for this side. So it is equal to -4 remains as it is, plus inside bracket -6 is stays as it is, plus same sign always results into positive sign. So we give a positive sign, it becomes +3. So which is equal to minus 4 plus inside bracket minus and plus. Minus and plus means it is subtraction. So let's do a subtraction in the rough area. 6 minus 3 is equal to 3. Answer is 3 and answer gets sign of the greater number. In this case it is 6. So its sign is minus. So our answer is minus 3 here. So that is equal to minus 4 plus minus. Plus minus different signs, which means it results into minus. So minus 3. Now minus 4 minus 3. Equal sign means it's addition. So 4 plus 3 is 7. And 7 gets sign of the greater number, which is minus. It's 4 here and its sign is minus. So minus 7. So now if you can see here that both sides the answers are equal. Here also minus 7 and here also minus 7. So even if we change the order of the operation, we see that the answer is not changing. So we can say that integers are associative under addition, or addition in integer is associative. So let's go and update our chart. So what we say is addition under integer is associative. Additive identity. Now, what does additive identity means? Let's put it in some numbers. So if I have a number, let's say if I have a number minus 6, I add some number, and I get the result as minus 6. Let's take another. If I have plus 3 and I add some number here and I get answer plus 3. So what should I add here? It is obvious that the number is not changing. So if I take a number like now, where I am right now, in first example, I am at minus 6. I am at minus 6, and where I have to reach? I have to reach to minus 6. So I am at minus 6 and I have to reach to minus 6. So how many places I have to travel? 0 places. I don't have to travel anywhere because I am already at minus 6. So what I have to add? I have to add a 0. Then I will be at minus 6. Now let's say, now in the second example, I am at plus 3. I am at plus 3. And where I have to reach? I have to reach plus 3. So how many places I have to move? I don't have to move. I have to stay there. So I have to move 0 places. So from this, we know that our additive identity is 0. So when we add 0 to any of the integers, the answer is that integer itself. Let's update our chart. So additive identity for us is going to be 0. 0 is the additive identity. So I'll write it here as 0. Okay. Additive inverse is a number. So if I have one integer and I add its additive inverse into that integer, I should get answer 0. That's what is additive inverse. So let's say I have the number as minus 4, then I should add some number into it, some number, so that I get a 0. Or same way, we'll take one positive integer also. So I have plus 3. I should add some integer into that so that I get answer as 0. So again, we'll follow the number line. It's an easy tool to understand this. So in first case, we said that I am at minus 4, I am at minus 4. I want to add some number into it so that I get 0. So where is 0? 0 is here on the line. So I have to reach from minus 4 to 0. So let's go. So I go from here to here, one place, one more, one more, one more. So how many places I have traveled? I have traveled 4 places. I have traveled 4 places. And which side I have traveled? I have traveled to right. And right means plus. We know right means plus. So I have added plus 4 into my number to get 0. Now let's take the second situation. Okay, in second situation, I am at plus 3. I am at plus 3 and I have to reach 0. So let me start 1 place, 2 place, 3 place. So I am going 3 places. I am going 3 places. And which side did I travel? I traveled to left. Left is negative. So I traveled 3 places to the left, which means the number is minus 3. So I have added minus 3 to my integer to get 0. Now let's observe here. In the first case, our number was minus 4. Additive inverse, we got plus 4. So which means 4 remained as it is. 4 remained as it is. So our number was minus 4 and in our answer also there is 4. So the weight of our integer is same. And what has changed? What has changed is the sign. Even in this case, my number integer is plus 3. So its weight is 3. So it remained same. The weight remained same. But what changed? What changed was the sign. It was plus here. In my answer, it changed to minus. So we can very well say that in additive, to find additive inverse of a number, the weight should remain same. Weight should be same. And sign will be opposite. It changes, so it is opposite. Okay, let's update our chart. So in this case, let's talk about, so additive inverse, same weight, and opposite sign. So let's revise what we have done today. So we did closure property, commutative property, associative property, additive identity, and additive inverse. The closure for addition, we found that integers are closed under addition. Integers are also closed under subtraction. We found that integers are commutative under addition, or the addition is commutative in integers, but subtraction is not commutative in integers. We also saw about associative that addition is associative in integers. We saw that additive identity for integers is 0. And for additive inverse, we saw that to find additive inverse, we keep the weight same and we just change the sign. We have opposite sign. Let's see. So try these from your textbook from page number 8. So the first question in try these asks us, write a pair of integers whose sum gives, and then we have 5 different things. So first thing is write a pair of integers whose sum gives a negative integer. Let's solve the first one. We need to find a negative integer when we add any 2 integers. It should give us negative integer. The easiest one is if we add 2 negative integers, we are going to get the answer as negative integer. Let's, for example, if I add minus 4 and minus 3, these 2 integers, so minus 4 plus minus 3 is equal to minus 4 plus minus, different signs result into minus. Minus minus means it is addition. 4 plus 3 is 7, and the sign of the greater number, which is 4 minus. So we get answer minus 7. So if we add any 2 negative integers, we are definitely going to get the negative integer. So that is the easiest one. We have more solutions to that. For example, if I have a positive integer plus 4, then what I need to do is I need to add another negative integer whose weight is more than the positive integer. So weight of this positive integer is 4. So I take another integer whose weight is more than this and sign is opposite. So I take minus plus 4 and minus 5, let's say plus 4 plus minus 5. So what I get is plus 4 plus minus results into minus 5 plus and minus here, which means it's a subtraction. So if I do subtraction, 5 minus 4 is equal to 1 here, and the sign of the greater number, which is 5 here, so sign is minus 1. So I get a negative integer. So these are the two ways to find two integers whose sum gives negative integer. The second one is 0, and that's very obvious. We know that a number and its additive inverse always gives 0. So we do not need to go further and discuss anything. If we want sum to be 0, it has to be the number and its additive inverse. So let's do the third one. We need to get an integer smaller than both the integers. So when we add both the integers, this result has to be smaller than them. In this case, we need to have, so let's say I take one integer. If I take one integer, which has to be smaller than that, let's say I take positive integer and I add a positive integer, I'm going to go right. So I'm not going to get a smaller, I'm going to get a greater one. So I can't use add a positive integer. If I add a negative integer, let's say I add minus 3. Minus 3 means I have to move towards left 3 houses. So I have plus 2 and minus 3. So I start from plus 2, I go 1, 2, 3, I reach minus 1. But minus 1 is not smaller than minus 3. Minus 1 is actually greater because we have to move to right. So greater than minus 3. So we cannot use this. So what we need to do? We need to take a negative integer. Let's say I take a negative integer, minus 2, and I add to that another negative integer, minus 1. Okay, so because I have to add minus 1, I have to go left. So I give one house to the left, and I get answer minus 3. Now you know that minus 3 is smaller than minus 2 as well as smaller than minus 1. So the answer for our third one is that if we want to get integers smaller than both integers after the sum, both the integers have to be negative integers. So then it's very easy. So both the integers have to be negative integers. So what we can have? Minus 3, minus 4, minus 5, minus 11. So we take any two negative integers. Their sum is going to be always smaller than both the integers. We'll do the fifth one first. We want to take an integer greater than both the integers. So in this case, it is obvious that if I want the integer to be greater than both the integers, I have to take both positive integers. Because if any of them is a negative integer, I am going to move towards left. For example, let's say I take minus 1 and plus 5. So if I take minus 1 and plus 5, so I start at 5, I have to go one house towards left because it is minus 1. Okay, if I take 5 and minus 3, again I have to move 3 places to left, and when I move left, I'm going to get a smaller answer than my starting point. So I cannot use the negative integer, so I have to have all the positive integers. So if I have used, let's say I take first integer is 1 and I take the second integer as 3 plus 3, then what I have to do is 1, 2, 3. I get answer as 4. So I took integers as 1 and plus 3, and my answer is plus 4. Plus 4 is greater than plus 3, yes. Plus 4 is greater than plus 1, yes. So to get an integer greater than both the integers after the sum, we need to have both the integers positive integers. Now we know to get an integer smaller than both the integers, we need to have both negative integers. So we want smaller than, then both should be negative integers. We want greater than, then both the integers should be positive. Now we want an integer which is smaller than one integer and greater than other. That obviously means that we want one negative and one positive. Any of the numbers. So one number should be negative and one should be positive. So let's take an example. Number line is a great tool to explain these patterns. Okay, so let's take one negative number. Let's say I took negative number -3 and I took positive number as +5. So I start from -3 and I have to move 5 houses. So I start from -3 and 5 houses. Which side? Positive side. 1, 2, 3, 4, 5. So I move to 5. So my number which I get is 2. And my initial numbers -3 is here and 5 is here. And now we can see 2 is between -3 and 5. So 2 is greater than one of the numbers, which is -3, and smaller than the other number, which is 5. So when we have one positive integer and one negative integer, their sum always gives the answer which is in between them. What we talked about till now was about the sum. When we want to do the difference, the dynamics changes. Because when I say difference means subtraction. So if I have subtraction and if I have any positive number ahead of subtraction, so let's say I have positive number ahead of subtraction, then minus and plus sign together, different signs result into a negative sign. If I have a negative integer after subtraction, if I have a negative integer after subtraction, minus minus, same signs result into plus 3. So the sign of the integer is reversed when we subtract that integer. So to get the answer as a negative integer, the difference has to be negative integer. What we need is, we need the first number to be negative. The first number to be negative, let's say -5, and the second number has to be positive number. Second number has to be a positive number. In that case, -5 minus plus 3 will convert into -5, minus plus goes into minus 3, and that will minus is addition, 5 plus 3 is 8, and sign of the greater number, which is minus 8. So we get a negative integer. So we have the first number as negative and the second number as positive number. We can definitely get answer as negative integer. We want to get a zero. We saw if it was sum, we used the additive inverse, but this is a subtraction. So we will not use additive inverse, but we will subtract the same number. So if my first number is -5, my second number also should be -5, because -5 minus -5, which will means -5 minus same sign will convert into positive, plus minus and plus different signs, so we need to do subtraction. Subtraction of 5 minus 5 is going to be 0, and no question of sign here when we have 0. An integer smaller than both the integers. Now when we did that for sum, when we wanted an integer smaller than both the integers, we both of them negative integers to get integer smaller than both the integers. Now here we want to do difference. So which means what we need to take is, we need to take the first number as negative number and second number has to be positive number, any positive number. Because when we subtract this positive number, it is going to convert into a negative number. Let's see, -5 minus subtraction plus 4. It will convert into -5 plus minus different signs converts into -4. And now we see both are minus signs. So it will be addition. 5 plus 4 is 9. And the sign of the greater number 5 here, which is minus. minus 9. We'll get minus 9, which is going to be smaller than both plus 4 and minus 5. So what we need is first number has to be a negative number and the second number has to be a positive number. We want the integer greater than both the integer. Now exactly opposite of what we did earlier, which is first number has to be positive number and second has to be a negative number. That way what we'll do is plus 4 minus minus 5 plus 4 minus minus same signs result into plus 5. Plus is addition, 5 plus 4 is 9 and sign of the greater number plus 9. Plus 9 is greater than both plus 4 and minus 5. The last one, an integer greater than only one of the integers. An integer which is greater than only one of the integers. Let's say I select an integer as 5. Now I want to subtract one integer from it and I want the answer should be in between those integers. Now let's say I want to subtract, let's say 1. Okay, if I subtract 1, then where I will go? I'll go to 4. Yes, I can get in between. If I subtract 2, then I'm going to go to 3. But if I subtract 3, I will go to 2 and 2 is not going to be in between 5 and 3. So this is a little tricky situation. So please remember that the integers which you choose, their weights, the difference of their weights. So if I choose 5, then I should choose the other integer. Okay, if I want to choose 1, their subtraction has to be in between them, the 4. 5 and 1, the subtraction is 4. Yes, it is between 5 and 3. Then the subtraction is 2. It is not in between. So the second integer which I select should be always less than half of the size of that integer. So if I select 5, what is half of 5? 2.5. So second integer has to be less than 2.5. So which is the integer closest to 2.5 and less than 2.5 is 2. So I have maximum I can select is 5 and 2. I can't select 3. So if I select, let's say, first integer as 7. If I select first integer as 7, half of 7 is 3.5. So the second integer has to be less than 3.5. So it can be 3. So 7 and 3 will give you answer. 7 minus 3 gives 4, which is going to be in between 7 and 3.